Hello and welcome to another episode here inside of the Photography for 3D Artists series for textures. And I say this on purpose because today I want to focus here on tone mapping. And I have made up my mind already, local, global, or not at all. So I have said my opinion, I can go now. Now, to make it really clear and simple, I do not want to talk against tone mapping, because it's just one more option that we have as artists to express whatever we like. And when our target is to express something that comes close with the options of tone mapping, then we need to use this. But in the moment we have no understanding what tone mapping finally means, any artistic approach is of course questionable. And so we have to talk about a local and global tone mapping. And I think some people really believe that's something new. And that's of course not the truth at all. And I think the most important artist in the last century, at least, was Ansel Adams. And he has described the whole process really in detail. So what is tone mapping finally? And I guess we have many more definitions than I present here. So bear with me when I do not go 1 hour long and represent all the ideas that I have collected so far. In a nutshell, and with the simplification that I like to do here now to save your time, when we have a scene, and normally we have with these curve diagrams in, and here is the output normally. So we have a scene with maybe something that can capture the light as it is in reality, HDRI for example. And then we have a medium that has maybe just LDRI, low dynamic range, as output. And the simple way how we used film was just we used the dark areas very flat, then we went straight, and then we rolled out the highlights. And the tone mapping was of course just to compress the white space into a smaller space. That would be then something like a global tone mapping. And the mapping is of course here in the curve. And when you think that that straight line here is now anything that has something to do with linearization, that's a misconception that I have met more than often in my hands-on classes. This straight line here represents only a straight line when you have here a logarithm inside of this axis here. And this logarithm goes here maybe with stops, for example. Each stop is double. In linear values, that would be here then 1, 2, 4, 8, 16, and so on. And you get the idea. And here it would be 5, and so on. And with the stops, we get with each step the double amount, and then we get here a straight line. So if I would take now here a linear line, the whole thing would look completely different. But I have the feeling I digress here already, so I put this here away. And global tone mapping means nothing else. We have a huge dynamic here and a very small dynamic here. And then we try to find something that gives us here an option just to go here very fat into the system, and we go out with a small dynamic range, or LDRI, low dynamic range, out. This would be here tone mapping, the simplest form I can think of. Okay, I think you get already the idea, and what I want to do here is of course to go a little bit more in detail. The other main use, and you will see that more than often, and hopefully you didn't notice it, is when you have, for example, a film image or just a photo. Maybe we have a volcano island here, and everything here on the floor is completely with black stones that you find maybe in Spain or something like that, near Africa. And on the horizon we have maybe a sunset. So we have here a lot of light, red, yellow, glowing, and then it goes here in dark blue. To capture such a scene is sometimes very difficult, and maybe your eyes are only here on this area where the sun is and the nice orange red tones, and maybe we have here some highlights on the black stones, so we are interested in these as well. But the truth is, if you want to have any usable detail here in the black stones, you have a huge problem, because the dynamic range between such a black area and here such a very whitish orange area is huge. And the more the camera looks directly into the camera, and you don't want to have the sun just being blown out to white because it's a sunset, so you go down in your exposure a lot of steps to get exactly these colors right. And then everything in the foreground completely black is just black and is eaten up by noise. Note always, noise eats dynamic range. And so the simple way is normally you split this image here, and you take here for this part a different exposure than for the black part. And then later on you mix these two images just in Photoshop. And this is then just a 2 exposure combination. Sky replacement is maybe the most used in this area, and it's more than often used when you have to use maybe a video camera with a low dynamic range. Not so much when you have maybe a red with HDRX or so. Then you can get away maybe with a lot of stuff more at once. So having said that, when we want to have a huge dynamic range into a smaller area, then we use tone mapping. And there are different ways. We have captured already a little bit the global one, and the local is of course the most sophisticated one and the most complex to organize finally. Global means that we use all the data in the picture at once. Local means that when we have a picture and we have different brightness values in the picture, maybe we have here a very bright light source and everything in that area is pretty bright, then we have here a foreground element which is maybe pretty dark, and then we have here maybe an option to look into a house, for example, and inside the house we have then here some candles sitting. So we have a huge dynamic range in the picture, and we want to see of course everything at once. And then we use a local tone mapping procedure, and that means the algorithm tries to figure out what is finally the brighter area, what is the smaller area, and then it takes something like these areas here, and these areas here, and tries to find this little curve that I have discussed before from film with the rolled out highlights and so on, and tries exactly to compress only these areas. Some books say it goes pixel by pixel, but one pixel by itself can't be compressed. It needs always a neighbor. It needs always something to relate on. Otherwise, you have to just take all pixels to the same brightness values and leave the colors there. That would be the same as to put 50% gray and in lab mode in the lightness channel. And the local process is of course pretty difficult. It can be that the area where the brighter values are a little bit wider than it should be, and then we get these halos, for example, around objects or all these artifacts. And so all these adjustments are needed. I will discuss this a little bit on a practical example, of course, in a second. The idea is normally that our eyes go through an image or through an reality through a scene, and looking here to this position, then it goes to this position, for example, and then to this position, and each time the iris adapts, and a little bit the chemical process in the eye has to do with this as well. On the end, we memorize this area, we memorize this area, we memorize this area, and the whole picture is very available to us. You can see this process simply by watching painters painting these areas. They work on this area, then on this area, then on this area, then go 1 time or 2 times over everything again to balance everything a little bit. And so the higher adaptive view will be represented more or less in the picture. I save our time now and try not to discuss if that is HDR anymore. We all have our opinion about, and it's not important which name we give that. Anyway, what I want to discuss is of course pretty simple here. and that has to do with the oversaturation of those images. And this is of course something that we can decide as artists, but for the textures that's not really acceptable. When we have here our curve again, and I make it pretty fast and short here, we have here our dark values, the blacks, and here we have our white values. I simplify here, and here the mid values. This is the area where we perceive the most saturation. When the colors by itself, all three of them, RGB, goes more and more to white, then the definition of saturation, which is a relative phenomenon, is gone, because the difference between these channels is pretty low. If two of these channels have a wider distance, the overall brightness goes also down, of course, but the saturation is higher. If all three goes down, then the difference between these three values, RG and B, is also less, and so the saturation that we perceive is also down. Then comes the idea, we have these values here, and we go with the brightness values, and we find a position pretty much in the middle field, and we leave all the saturation in the way it was before. And that means we get all the saturation, but the brightness is down. So the saturation, and I will show you that soon, is not moving with it. It stays, and then it becomes really, really intensive. I try to stay neutral here, and it's of course nothing that we want to use in our texture. So why I say this, that we don't want to have it? Okay, I need a little bit space here. And as we have seen here, we have here our local adaptation from the eye. Again, the eye. The eye looks here, the eye looks there, and there. Just the three examples. When we take now one picture and we do not go finally after the adaptation with that low brightness contrast here, we need to stay in the middle, because in the moment we expand from here again, we distort more the image, but more importantly, we create again bright and dark areas in the picture. This time a little bit different, of course, and our eye starts to adapt again. It doesn't adapt so much to saturation, it adapts to brightness. And in the moment it starts to adapt again, the whole process, or what makes finally sense that we represent an adaptation process, is gone. And when we take now here on my standard cube that I have in mind, oops, that should be straight here, of course, one texture here, and we take another texture in our scene here. Then we place a light, a camera here, and then we move the camera from this position to this. That means we get a change inside of the scene, and with the change of the scene we get different brightness values normally, and then our eyes adapt all the time to a new scene. And so the whole idea of representation or simulation of local adaptation from the eye represented in a picture is gone, and so the whole texture here is maybe more questionable than before. Just a little hint why I think it should be tone mapped after the rendering if you want to have that effect. But as an artist, you have to do whatever makes the most sense to you. I have no input in that, and I have no critique in this. So forgive me when I go here a little bit closer to the artist area than I had intended to. But local adaptation has something to do with the whole idea, and when it's not correctly applied, then it falls apart, of course. Let's have a look to an example. Of course, I went out, and as you can see here, we have here already some little points, and I go very close to it so you can see this maybe in a better way. All these bright little sprinkles here, these are highlights. There is some reflective material, iron or something like that, in this stone, and so I will show you that, of course, more in detail. I have created an HDRI out of 15 exposures, with each time exposure value between, one stop. And you can see here I have used two different objects in the scene. One time a small color checker here, my passport, the little one that I have with me, and a Kodak grayscale map, and it's normally between A and B to have the white and the black point. M is the medium, and these three here gives me then just a measurement that I have some space in the darks, there where the noise should be. And so my black has of course not one value, it's of course an area of blacks, and it needs to go from this value to this value to have the whole space here of the B. And if I would have here already a black, then I would have no dynamic anymore. And here's the noise, of course, that means the dynamic goes really down. That is why we normally don't expose to absolute black when this here is the black point. You can see this here is much darker than this little field here. Very simple to see. So having explained this, 15 exposures, and you can see we go here up, 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 and I have used this small increment here to really get a nice flow of data, and it's nearly gone here. I should have taken one more to really close this, but I think it's not necessary. That's black, and to go here now with black values until they disappear, I thought that was not needed. I have put this all into Photomatix then, which gave me then this result, which I saved as OpenEXR file, of course, 32-bit float. And in Photoshop I have set then our medium point here, our mid gray, if that is 0.18 or 50%. It's maybe a longer discussion, but we have some agreements about this, or you have to stick with one value that you take through your whole pipeline. This needs to be set up after you have created an HDRI. Typically you can do this, of course, with the exposure adjustment layer. And one word to this little guy, this works only in linear. If you try to do this with gamma-based material and you go here just in the exposure higher, I have shown that in another series, you will have trouble. If you shoot with your camera 2 stops apart and you take the darker picture and add 2 exposure values on top of that, you will see these two will not match up, because a gamma-based image will take no advantage of this here. In linear that works very nicely, but in the moment you take here this middle gray and use this here, I'm not really happy, to be honest, to use this all the time. It's a good idea to use it, it's maybe possible, but I want to show you, of course, another one, how we can do this. So I go here to my color picker and I put here 018, 018 and 018 into that, and this gives me here that middle gray for linear. Then I take a normal layer here, press the command key because this chip is now in the background, and press delete, which fills the foreground here. Then I stay in this layer here and set this to difference, and you will see immediately the M is here the darkest color, or the darkest brightness value, or whatever. And so when we move now here with the exposure, you can see that this field moves here, and you can see very nicely based on the scale where you are with your values here. And when I move this up again, I go over that point, so I can see here clearly. When I switch it off, I'm pretty there. This was my target here. This has a different value here, so I could move it a little bit to adjust this. But you get the idea. In a moment we have the same value background and the layer 1 here, then we have exactly the middle value of 0.18. So I take this here away, and of course we could go, if Photoshop would have a curve in 32-bit, we could go now here, of course, and set this to neutral gray and then adjust here, because I see here that is always a little bit tinted, a little bit red, but maybe I'm too picky with that. Just to say what I have done. So back to Photomatix, and here we can see already that we have a complete different representation of an OpenEXR file. Photoshop tries to tone map this, of course, and takes a different approach than Photomatix. So what is finally the right one? It's up to you. This is maybe here completely blown out, but we could see some of these tones in Photoshop. I wouldn't go here now and discuss this because the main idea here is the tone mapping part. But before I do this, I want to show you here, of course, the Hdr histogram. And we can see here clearly it starts here roughly at -6 and goes here nearly 2 or roughly 2 plus 2. 8 stops. 8 stops is not little, it's not a lot, but it's a fairly good amount of light that we have captured here. And the truth is it goes here way higher. So we have here something that goes beyond, from my point of view, the camera that I have here, that I could normally capture with one shot. That might be here the little highlights that I have, or that might be here that stone finally that produces this, because you can't see here really huge amounts of the picture. And keep in mind, we have here 3 mountains in the histogram. Just memorize this. A very fat and flat, medium high, very high, and then down. Memorize this. Okay, so now we go to tone mapping, and the first representation is here a complete different one. We have only 2 high areas and it looks something happens here. So let's have a look. I go here to the default and I go down here. That means from left to right and then down again, and have an eye on the histogram and what it does to all of these gray fields here, because that's a huge indicator what finally happens to the picture and how flat it becomes from time to time. These are all just presets, so I don't do anything bad to the image. It's just what the presets gives me here, and that's of course the most comparable thing that you can have here when you do your own stuff. And you can see here sometimes the gray chips from these nearly vanishes, and the histogram does a lot of dancing here, and there's a lot of change. And this change is based most of the time, especially with the detail enhancer of course, based on local tone mapping. And this is a distortion of the curve on a local basis. That means you have no chance, from my point of view, to get this out of the picture at any time to linearize your image after a while. Once applied, it's gone. And that's pretty much what it is. Okay, I think you have seen what I have in mind. And by the way, the most important part here when you go to the tone compressor is of course that you know these areas, and for that we have here these little info views also on the detail enhancer. And when you check off this little box here, you get the most important slider for the whole thing here. It's the light adjustment, and you see it's like a cloud is moving here behind, and this is more or less an adjustment where these areas are that are affected by it. And then of course a little bit saturation back into it, maybe not that much, and some other settings which are discussed more than often on the web. And I think if you need this, you get maybe some nice information in it. Okay, back to Photoshop. Also here I want to use the tone mapping options, and I want to give you of course a little hint here. This little slider gives you a first idea what you have here inside of your picture, and a double tap here or a double click brings you back to the idea. What you can't do in Photoshop, what is possible for example in Nuke, is to introduce negative values. So when you adjust maybe here the medium, it might happen that some flags slide into the negative area. That's not possible. When something is negative or should be negative, it goes just straight to 0 and then it stays there. And when something is 0, you can see that when I add here 20 exposure values, you see here these yellow chips. Something is not exactly where it should be. Values with 0 are always a little bit difficult. But more difficult than that is of course when you have values that goes into the negative area or values that goes into infinitive. And these two areas are very hard to fix. And so one way to fix this, if you get an image that has that problem, is to create a new layer, go to your color chip here, put in 0, 0, and 0, and fill the whole thing, Option Delete, or Option Alt, and that needs then to be set to lighten, black lighten. That means we add exactly this on top of that, so anything that is negative in the picture becomes now 0, and it should be a little bit better than before. Just a little hint. Okay, so back to our theme, and we go here now to image, to mode, and to 16-bit per channel. And this gives us then here the HDR toning option. If you want to have the image exactly as it is on your screen, then exposure and gamma, everything to 0, or exposure to 0, gamma of course to 1. That means straight. And then we have here of course several options. Local adaption, which we have discussed of course with photomatics, and we can see here we can create some local adaption effects here, not as much as with photomatics, but we have here a wonderful curve, and this is of course not a representation of the curve that I wanted to have here, because after we click here we end up in 16-bit or 8-bit even, and so we can adjust here values, and when I take the strength here away I can see a little bit more what I'm doing with my curve here. And I've done this here not for use for textures, and this would be here maybe something that I would try to avoid at all cost as a result for textures here. And we have other options. Equalize histogram. That means the histogram that we have seen now is taken without any intelligence in terms of color or what we have in the picture, and is just equalized, so to say, and it's all the same then. And that gives not repeatable results with different images. Highlight compression is more or less something that rolls out the highlights. Also a distortion of the curve, and exposure and gamma is relatively neutral, but it stays then in the 1 or 0 to 1 area of the 16-bit, and it cuts pretty much everything away that is beyond or above. And I want to show you of course something very fast, very quick. When I go here to this area and I go to filters and to Gaussian blur, I click here, and when I increase here the radius, you can see maybe the blooming here of these little guys. This can be dangerously when you have those things in your texture and you don't want to have them, because they are relatively to the camera, the subject, and the light source. In the moment you move the camera or the object or the light source or everything together, these effects will start to change, of course, because you can't see them here or here or here so much, and so they bloom. That's not funny when you want to have, of course, a natural effect here. And that sums it up, of course. If you have a picture like this, please make your exploration. What happens to the shadow? What happens to the color chips? And what happens finally to the dynamic of the texture that you want to have, or this texture here? And from my point of view, I think I have made clear why we try to stay with the linearized information that I have created with my HDRI, and I have placed this in an OpenEXR after the fact that I have created the HDRI. So after I got the linear material, I haven't touched it except for an offset here, or an exposure change to be more precise, to get here my standard value that I have applied then hopefully to all textures, so we have the same light intensity in all of these textures. Thanks for listening. Have fun with it. Bye bye.